Good morning, one and all. Uh, we are presenting this paper, Layered Service Model Architecture for Cloud Computing, written by Prajwal, Bhardwaj, Kaustubh Lohani, and me, Vishal Kaushik, who will also be presenting it before the August gathering today. Uh, our motivation towards this area actually was based on the NIST model, which formally standardized and defined the cloud computing services delivered to the customers from the service providers. Though cloud computing was there, started as a business earlier, before earlier to 2011 by the companies like IBM, Microsoft, HP, and all. They started offering services pay-per-use model to their customers, which was finally formalized by NIST under the heading of three categories based on the business requirement, functionality, and control which is provided to the customer or which is shared among the customer and the provider. So the models were namely as IaaS, Infrastructure as Service, Software as Service, and Platform as Service. After this has been passed around, a decade, and some new technologies and computing methods have also emerged out, like serverless computing or container as service, etc., which actually do not theoretically, practically as well, not fit at all in any of the category of IaaS, PaaS, and SaaS. So today we will be discussing about the background of research and how we are going to take it further, because we will discuss that why there is a need to think beyond the NIST model and already existing approaches which are alternative to the NIST model. We will also propose our own architecture here, and then we'll map it on the existing cloud platforms and products to the proposed architecture. We finally be having a word on the future challenges and the ways out for further researches. So let us discuss upon the background. Cloud computing, as everybody knows, and is well defined by NIST, that is a computing model that enables ubiquitous, convenient, and on-demand access to a shared pool of computing resources that can be rapidly provisioned and released with minimal effort. Cloud service provider is one such stakeholder in the entire cloud business. The cloud service provider is the one which offers the on-demand or caters to the on-demand services to the clients. Cloud service provider offers the service under the head of one or more service delivery model defined by NIST. Service delivery model defined by NIST are IaaS, PaaS, and SaaS, as everybody knows about it. Infrastructure as service is nothing but where a customer is provided with computational resources, where the customer has the freedom to choose its own software he can install and run on the machine, on the computation resource. So customer can choose the operating system or application server, etc. The examples to it like Amazon EC2, Azure VM, Google VM, etc., etc. Then comes the platform as service model, which provides a customer with the capability to directly deploy a custom application or any acquired application on the cloud infrastructure using the programming languages or the libraries, tool or services which are provided by CSP. Software as service is a service model where cloud service provider will provide the customers with a ready-to-use applications on the cloud infrastructure. So everything is managed by the service provider only, and the customer is just there to use that application without having any botheration to install and manage the configuration even for that application. Then comes the new methods like serverless computing, where all the computing resources are offered by the cloud service provider. Only the customer is ordered to have the implementation of the computation function with a piece of code he wants to execute during the call. Then comes the container. A container is a executable unit of a predefined or customized container image that generally encompasses one or more software programs to deliver an application or service. But container is having a little difference from the infrastructure VM, because infrastructure is something which is created on top of the virtual hardware or hardware after virtualization, whereas the containers are something which are created on top of the operating system using the container engine. That is this diagram that is going to give us a clean glimpse of that how there is a requirement, why there is an ambiguity, and where that ambiguity is all about and confusion is all about. This diagram talks about the control offered in cloud infrastructure. Who does what? Who controls how much and what? Under all the headings as defined by NIST. So NIST says that infrastructure as service. Infrastructure is nothing but an amalgamation or a combination of networking, storage, servers, and virtualizations, all managed by the service provider. Whereas the OS on top of the hardware, the middlewares, the runtimes, the data applications are managed by the customer. Then I'm leaving the containers here for a while. Then comes the platform as service, where up to the runtime, everything is managed by the cloud vendor, whereas data and applications are managed by the consumer. I'm again leaving the serverless computing here for a while, and SaaS comes on as a service model where everything is managed and controlled by the consumer. No, sorry, not the consumer, by the service provider, and consumer is just there to enjoy with the usage of the service application. Now just have a look at this line O and A. Line OA is actually offering the control. Below anything below it is controlled by the vendor, and anything above it is controlled by the consumer. This line is a clear indication, and this line is they are bifurcating the two new services and in an ambiguous manner, like operating system, like application backend in serverless, and operating system in containers. So there is a need for which we cannot actually theoretically and practically also we cannot keep it segregated under one or the other. Hence, there is a need for a new approach. Now, are there new approaches already been there? Yes, definitely there are new approaches been there. And why there is a need? Because containers are considered as infrastructure, but containers, as I've earlier told, are on top of, are created on top of, or offered on top of the operating system using the container engine, whereas the virtual machines infrastructure is created over a virtualized hardware. Same way, serverless computing provides a feature list that combines all three: infrastructure, platform, and software. So consequently, classifying the serverless as one of the NIST service model is not at all possible theoretically and practical as well. So there are, yes, there are alternative approaches available, but what has happened that out of the marketing terms, the companies have been offering just as a marketing stunt to their services, like healthcare as service, disaster recovery as service, IBM's business process as service, privacy as service, etc., and many other like. So they have come up with the concept of SaaS, means anything as a service. Just put an AAS after the name. This is again more ambiguous. This is again more confusing because there can be a synonym for a word, like healthcare can be said medical service, medical as a service, or medicine as a service, like that. So there will be a confusion among the integrators. There will be a confusion among the consumers and also the service providers as well. So these are the problems which actually lead the way to new approaches. The alternative approaches are there, existent, and are proposed by few scientists or researchers earlier. Like one is the most popular one is John Denham's framework. John Denham's framework says the cloud defined as service layer architecture. So he says layer 0 is the abstraction hardware, layer 1 as software defined infrastructure, which is talking about the infrastructure and is also used by the infrastructure users. Layer 2 is foundational PaaS, which is for the developers, DevOps developers rather than development operations, DevOps operations. Layer 3 is PaaS, which is again used by the simple developers and coders. Layer 3.5 is in addition to the John Denham's model by Miyachi Kirstein in 2018. Which is talking about serverless computing, which otherwise was not available there at John Denham's model. Then we have the model-driven PaaS, which is for rapid developers, and app services, which is for citizen developers. The normal developers are there. And then it has finally ends with SaaS for normal end users. But the problem here with the John Denham model is that the container as service is not at all to be fit or cannot be included in as a separate layer in this framework, because though it has tried to put container in PaaS, but it is actually not the correct truth, as we all know about it. So foundation PaaS is what? It bears the slight difference from CAS. Foundation PaaS is a layer on top of the infrastructure layer that gives the developer prepackaged tools and ready-to-use hosting environments, whereas a container is something which is provided as a pre-configured environment to work with, a prepackaged development environment. Okay, so is offered by the CSP using the container engine. Okay, that is virtualizing the operating system already, and it is deployed on any infrastructure. So due to this slight architectural difference between CAS and foundational PaaS, the CAS generally offers more control than the foundation PaaS, as what we have discussed in the previous slides, previous few slides here. The proposed architecture that we say is that has got layer 0 to 8, 9 layers total primary, but 0 layer is termed for hardware, where we say hardware being the abstract and opaque from the customer, the topology of the hardware, the specification of the hardware, anything, networking of the hardware, memory chips, memory chips, number of processor cores, storage disks, everything is stored, is though collected together, work together, but is abstract from the customers. This model has been designed with fundamental components of named or classified as compute, network, and storage, and any level of abstraction or encapsulation onto CNS component of a layer will create into a new layer on the top of the previous layer. We have constructed the architecture such that the level of control over CNS given to a client will decrease as the layer increases. And layer 1 offers the maximum control over CNS, and layer 8 has the least control over the CNS. So this is how it is able to, resolve the ambiguity in a big manner. We'll show it also diagrammatically, as well as the mapping, with the mapping of the existing tools and services. So furthermore, the layer increases, number increases, the control of CSP over the product increases, while the vice versa. So just try to have a look at this now. The diagram, we can say the layer 1 is layer 0, okay, basically, which is offering the cloud own IT. And here these symbols are basically the intersection points and the availability of a particular under the head of these one or the other component here. So this is just highlighting the or presenting the availability of that component in on a layer. Okay. So layer 1 or layer 0 is nothing but physical hardware, like company's owned IT or on-premises or off-premises cloud. And layer 0 is nothing but an abstraction of CNS components. So abstraction is there, present everywhere. So there is a new additional layer is there available on top of it. Layer 1 is virtualized layer. This layer comprises what? The virtual machines, networks, and virtual storage, which is created using the abstraction over the physical hardware, using some piece of softwares like the hypervisors like ESXi or KVM or Hyper-V or whatever. So product at this layer offer the virtualized hardware components used through the some or the other virtualized hardware components. Hardware virtualization offers almost similar level of control as a physical hardware, but it is more reliable than using physical systems. Example to it is Amazon EC2 with the coordinate of the service as 1C, Azure VM again the coordinate as 1C, Google Cloud Engine or Compute Engine as 1C coordinate. So some of these services followed under the layer includes EC2 and Azure virtual machines. Then coming on to the next layer, layer 2, which is container as service. This layer comprises container management products and products that virtualize upon the hardware using an additional layer of container engine. This layer offers control over the OS as opposed to the virtualized hardware. Example to this is like Docker, like Google App Engine, etc. The foundational pass is something which is providing the various products that offer the client a platform for their development task. Okay, pre-installed libraries and dependencies according to the specification which is provided by the customer. Sorry, the example to it is Amazon S3, which has the content now become 3S, and Docker Swarm. Docker Swarm is offering the coordinate as 3N, which is offered at that layer. Swarm network, and S3 is the storage bucket, where there is no requirement of compute, okay, because it is an object storage here. Then we are coming on to the layer 4, which is PaaS. So products at this layer should be providing a specialized platform for a specific task, such as code execution and deployment. So this provided platform will perform the task with the pre-installed libraries, and no library could be added. Like Azure Bots, the component coordinate for this is 4C. Like RDBMS, Amazon ARDBMS, 4S with the coordinate of to this. Then we say serverless computing. Serverless computing is again offering the platform for carrying out application development and deployment. Like any other category layers, products at this layer do not let the user control their execution servers. Example to it is like Amazon Lambda, which has the coordinate 5C, and then we come on to the layer 6. The product which is there at this layer, such as the developer with a platform containing ready-made parts like Azure Logic App, which has been the coordinate with of 6C. Then the layer 7 is application layer, application services layer. Application services layer will the product will offer a choice to create a final application by repackaging ready-made components like Azure Site Recovery, 7CNS, present everywhere, and Salesforce, again 7CNS, present everywhere. The products here offer a choice to create a final application by repackaging ready-made components. It has got maybe unlike the built-in pass, offers a developers control to choose from the components and customize their these components. Then layer 8 is SaaS application, which has contained the ready to use which contains the ready to use applications and products like MS Office 365 8, CloudWatch 8 from Amazon, and Active Azure Directory. Like so, this layer we have got the coordinates as 8. So this way we are actually able to handle the ambiguity in a very good clear manner. And now just come on to the mapping part of the existing services. Like we have EC2 1C. EC2 is what? Virtualized hardware layer 1C. RDS is a database service 4 PAS 4C and 4S, sorry. And here S3 3S because it is the functional PAS. Similarly, we can have we can find out several other services mapped onto this, like IAM as 8 because a ready to use application. Docker as 2C. Here our Docker Swarm at 3N. Like this we have and Microsoft Azure Logic apps like 6C. So we have got finally Google Compute Engine 2C container engine, Compute Engine 1C, and Google Cloud Functions as 5C. Okay, so this is how we find it, and we have found that every application, every product is available and can be very easily mapped onto this model what we have approached and proposed. Okay, but there are certain future requirements for this. The proposed model work for foreseeable innovations in the cloud service methodology. Nevertheless, there is a new layer will be added, but again, at a time when there will be unmanageable number of layers, so that has to be addressed by further researchers. Addition of another dimension that can take care of maybe minor fluctuations in the delivery approach, resulting in a more clean model. And we have considered CNS, compute network and storage, as the means of cloud service delivery. However, there might be many other more ways to deliver the cloud services that has to be explored. The criteria to place products on a service layer are no means concrete or complete, and then thus there might be other parameters that should be concluded or included into the architecture. So just quickly go to the summary. In this paper, we have tried to address the issues of NIST service models categorization by proposing a new architecture, which is layered approach. We have proposed a 9-layer framework where each layer defines a separate service model, and we have also tried to shed the light on that topic. We should update the NIST model, and we argued that the technologies like serverless or CAS use a different approach fundamentally than the existing cloud approaches. So we need to have a different level of control. We need to offer a new approach or model to deal with and categorize them because of the different level of control they show. Okay, so the buckets of IaaS, PaaS, and SaaS is not fit for them. And finally, we have placed cloud services currently prevalent in the industry onto our model and showcased how our model easily categorize the already available services in the industry. With this, I would like to thank everyone, and we are more open for the question if there are any. I'm writing my email address into the chat box. Thank you.